Welcome to your video on the distance rate time equation. We're going to start our notes by writing down another new formula. The formula is D equals RT. Sometimes people refer to this as the DIRT equation, just helps them remember it a little bit. And here's what the different variables represent. D stands for distance. The units are always important. They'll help you figure out what number should go in what position in the formula. And for distance, you can measure those units in feet, meters, miles, and kilometers. Those would be a few examples. The R in the formula stands for the rate. Units we might use for that would include feet per second, meters per second, miles per hour, or maybe kilometers per hour. And again, there are many other options. It kind of just depends on what is set up in your problem. The T stands for time, and some units of time could be seconds, hours, minutes, or even things like days. Okay, now that you know the different parts of the formula, we're going to work through a few examples. The nice thing about these examples is you'll be using the same formula for every single one. So this first example, just take a minute to read through it, and then we'd like you to write down the variables. So just off to the side, put the D, the R, and the T. And after you've read through it, we want you to pause, and then just jot down what you think the D and the R and the T are, and then you can press play to find out what they actually are. So for D, you're going to write down 9 miles. And for T, you're going to write down 45 minutes. The rate is the unknown, so we're just going to put a little question mark there. Now, whenever you work a problem, it's always a good idea to start with the formula. So I'm going to have you write down D equals RT, and we're going to fill in the things that we know. So in place of D, we're going to put 9. In place of the T, we're going to put 45. And so the R is going to stay as a variable. And notice here, I did not plug the units into the equation. That just gets confusing. You've got far too much going on. So just plug the numbers in, work it out, and then we'll bring the units back at the end. So to solve this equation, we want to try and get the R by itself. And you guys may remember that we're just going to do that by dividing both sides by 45. On the left-hand side, 9 divided by 45 gives you 0.2. And on the right-hand side, we're just left with R. Now it's time to think about the units. We had 9 miles divided by 45 minutes. That means our units are going to be miles per minute. So it'd be 0.2 miles per minute. And you can write it out in words too. Okay, and then I would circle that answer, and that is going to be the rate at which Brady was traveling. Next example. I'd like you to do the same thing off to the side. Write down the D, the R, and the T, and then give yourself some time. So you'll actually press pause, read through the question, and then fill out the D, R, and T. And when you're done with that, then press play to resume. So for this question, the rate is 75 miles per hour. And the time is 15 minutes. Now, before we can actually go to our formula, we have to think about our units here. The rate is miles per hour, and the time is in minutes. And those two things do not match up. So you actually have to convert minutes into hours. So to do that, you just take 15 minutes divided by 60 minutes, because that's how many minutes are in an hour. And you'll find out that you're left with 0.25. You could also just look at a clock, and you know that 15 minutes is a quarter of an hour. So a quarter would reduce to 0.25 as a decimal as well. So either way. Now you can go ahead and plug everything into the formula. So always write that out first. D equals R times T. The D is the unknown this time, so we're going to leave that as D. The rate is 75, and then the time is 0.25. And you have to have that time in hours. Actually, I just noticed the label there is incorrect. It should not say minutes. The time should say hours. because the time has to match up with the units for the rate. And this one's pretty straightforward. You just have to get out your calculator and multiply the 75 by the 0.25, and you get 18.75. Now we are talking about distance, and so our label then would be miles. So it's 18.75 miles. Circle your answer, and then you are ready to move on. Our final example, no surprise, we're going to do the same thing here. Do the D, R, and T. And then you'll read through the question and press pause, and then fill out your information. And then press play to resume and find out if you were correct. For this one, our little snail is going to go 0.75 miles, sorry. And our snail is traveling at a rate of 0.03 miles per hour. And this time our time is the unknown. Just like the other ones, we're going to start with the formula. D equals R times T. And we're going to fill in what we know. The distance is going to get replaced with 0.75. The rate gets replaced with 0.03. And then the T gets left alone. To solve this, just like the other, we're going to divide both sides, this time by 0.03. And when you do that calculation, you'll end up with the time equaling 25. Which means it would take our garden snail 25 hours to go 3/4 of a mile. All right, this concludes your video on distance, rate, and time, and you are now ready to begin your practice.